Now that you've seen quite a few Cucumber and Serenity BDD techniques in action, let's try and take our Caffeinate Me application a little further and get a feel for what real-world BDD development looks like. We'll see how you would typically layer non-trivial step libraries using Cucumber and Serenity BDD. In the last lesson, we did look at quite a few techniques, but we probably put a little bit more complexity than we normally would into a single scenario. So this time we're going to start afresh so that you can reinforce what you've learnt so far and so that we can get a more realistic sequence of scenarios. Here we are back in the Caffeinate Me project. If you want to follow along at home, check out the Lesson 5 Start tag in the Git repository in the new branch. You can do this by opening the command line console or going onto the command line on your machine and typing something like git checkout -b lesson 5 exercises lesson 5 start. This will create a new branch called lesson 5 exercises with the starting point for the code we'll be using in this exercise. When the team talked to Barry in the Three Amigos workshop, they wanted to identify the simplest scenario that would add tangible value for the organization. Now, what do you think this might be? We might think of registering a user. A user needs to be registered before they can order with Caffeinate Me. But a registered user doesn't add any value if they can't actually place an order. So we might think of placing an order. Can a user actually submit an order? But again, the order is not much use if the barista can't receive it. So the team came up with the following simple scenario to start with. Buyer orders a coffee. So given Kathy has a Caffeinate Me account, when she orders a large cappuccino, then Barry should receive the order. Let's see how we would automate this. The first step is where our customer signs up for a Caffeinate Me account. Given Kathy has a Caffeinate Me account, let's create a class to contain our Cucumber step definitions. We can call it something like order a coffee step definition. Now we need to define a step definition for this step. We could generate them automatically, or we could just do something by hand along the lines of given Kathy has a Caffeinate Me account. Now for the moment we're not doing any variables here. Later on we might make Kathy a variable, so we pass in the name of the user. For the moment we'll keep it simple and we'll hard code it. Previously we saw how to use a step library to represent the actors in our scenarios. We're going to do something similar here. We're going to have a customer step library to represent Kathy. Let's implement this class. This will be a simple class for now, but we will make it extend the scenario actor class. The scenario actor class comes with the actor field we saw in the previous lesson, so we don't have to worry about coding it ourselves. Normally, a user would sign up online, so there'll be a web page somewhere where Kathy can do this, and we could use WebDriver to implement a web test to exercise this page. But as this registration is a precondition for our test, it's in the given statement, not the when. And it's not the main focus of this test. We would really prefer to do the registration via some kind of API or web service. To hedge our bets, we'll hide this detail behind another step library that we'll call User Registration Client. A user registration client has one job: to register a user. So let's make the register user method register Kathy. So now we have a register user method. What this means is that our customer needs to be able to be given a customer ID when she registers. We'll cheat a little bit here and have the user registration client generate the ID. Normally it would be returned to us by the web service that registers a client. Let's implement a has a customer ID of method to assign the new customer ID to the customer so that the customer can store their ID internally. I'm just going to create a field for the customer ID that I can assign with this method. We'll also need to be able to know the ID of a customer, so let's put a getter method as well. Now that we've implemented the first step, we can move on to the next one. The next step is when she orders a large cappuccino. Let's write the step definition for this step. Let's fine-tune this step definition a little. We can make it when he or she orders a large cappuccino, and large cappuccino is our variable expression. So we want to make this a dot star and pass it in as a parameter. Now we can call a method on our customer step library to place the order. Let's write the code we'd like to have. Kathy places an order for 1 large cappuccino. When a customer places an order, she should receive a receipt with the order number and a summary of her order. We don't know how the places order for method will be implemented yet. It could be through a web service or through the UI. But in both cases, we need to get some information back about the order that we can use in the following steps to retrieve the order from the barista's pending order list. Let's call this an order receipt. We need to store the order receipt in our step definition class, and we're going to need a class to represent our order receipt. An order receipt should have the client ID, the order quantity, and the product, espresso, cappuccino, and so forth. Let's create a simple Java class to hold these fields. We'll also get IntelliJ to generate equals and hash codes methods, because we'll need to be able to compare the receipts later on. It's also a good idea to generate a toString method to make any assertions that involve order receipts more readable. Great, now let's implement the places order for method. I'm going to mark this method with the step annotation so that it appears in our reports, and describe it so that the report will show something like Kathy places an order for 1 cappuccino. Great stuff. Now let's implement place orders for. Here we could interact with our applications through the user interface or through a web service depending on our testing strategy. But we don't want to commit to a solution just yet. So we write the code we'd like to have. What I'd really like to have is a step library that allows me to place an order for a given quantity of product items. So that's exactly what I write. Coffee orders place order for a particular customer ID and a particular quantity for a particular product. Now this coffee orders object that I've just created is going to be a step library. Let's call it something like coffee orders client. So now we'll declare our coffee orders client field, and we're going to define it as a step library. We're going to also say that it's shared, meaning that the same instance will be used no matter what step definition class we call it from. Now we create the coffee order client class, and we're going to implement place order. Now the role of place order is to place an order with our Caffeinate Me application and to return a receipt to the customer. Now, to place an order, we're going to store our orders in the form of an order class. Now, orders are a little bit more complicated than simply a receipt, so we're going to use a different class. Let's create the order class here. Now we can create the constructor based on our 3 fields, and we can initialize these fields using IntelliJ's autocomplete. So now we have a simple order class with 3 fields. Now we need to convert the order to a receipt. So we can create a method called getReceipt, which will return the receipt corresponding to a particular order. So a receipt, we're going to pass in a customer ID, quantity, and product. Let's get IntelliJ to generate the equals and hash code methods for us. And while we're at it, we'll also generate toString. Let's go back to the coffee order client class. The role of the place order method is to submit an order to the Caffeinate Me application. But for now, we'll just maintain a list of orders in the coffee orders client class. Clearly this is cheating a little bit because we're not actually implementing the application, but it'll do for now to help us define the services we need and to help us understand the layers we typically use in a Cucumber and Serenity test automation suite. So we'll just store the orders in a list. The last step we need to implement is the then clause. Then Barry should receive the order. Let's create the step definition. Here we need to check that Barry the barista can see the order in his list of pending orders. So we need to check that the orders that Barry sees contains the one that Kathy sent. One thing we could do is to make Barry responsible for telling us what orders he sees. We could give Barry a method like pending orders, which will return the list of orders that he can see. So how are we going to represent Barry? Well, Barry is a persona just like Kathy. So we could use a persona step library. Let's create one. We'll create a class called barista. And we'll annotate this field with the steps annotation. Like Kathy, Barry is an actor in our scenario. So our barista class will extend scenario actor. We can now go back to order a coffee steps definitions and remind ourselves of Barry's responsibilities. Barry's job is to tell us what orders he sees through the pending orders method. Let's implement this method now. There are a few ways we could do this, but in all cases, we're going to need to interact with the coffee orders client. So let's add a coffee orders client step library. We'll need the steps annotation, and we'll mark this as shared to make sure that we're using the same one as Kathy the customer. Now all we need to do is have our barista report back on the orders he can see. Let's keep it simple and add a getOrders method to our coffee orders client. Now this method will simply return a copy of the list of the current orders. And now we can update the return type of our pending orders method and get it to return a list of orders. Now back in the order a coffee step definitions class, we can see what we want to do with the pending orders once we've got them back. Now our job is to check that the order receipt appears in the pending orders, or more precisely, that the order corresponding to the order receipt appears in the pending orders, because our order receipt class is not the same as our order class, so we'll have to do a conversion somewhere along the line. We could use an assertion library like HumCrest or AssertJ to make this check easier to understand. I'm going to use AssertJ. In AssertJ, we would say assert that Barry's pending orders contains, and here we need to pass in an order that matches to the order receipt. We can't pass in the order receipt directly or we'll get a compilation error. So we need a way of converting an order. So we need a way of converting an order receipt into an order. Let's create a method in the order class called matching. And what this will do is return an order that matches a particular order receipt. So order matching order receipt will return an order. We'll create a new order and we're going to pass in some values. And it looks like we haven't got any getters on our order receipt. Let's just go into here and add them. We haven't actually needed them yet. So we only create methods as we need to use them. This minimizes the overhead we need on maintenance. So we say order receipt get customer ID, order receipt get quantity, order receipt get product ID. Now let's run this test and see if it works. In a real test, we'd run this against the unimplemented web service to see if it fails first. Oh look, it's failed. Looks like we must have forgotten something. Let's have a look and see why it failed. So it was expecting an empty list to contain an order containing one large cappuccino. That looks like we've forgotten something in our ordering process. It looks like we've forgotten to add the order to the orders list. So we create an order, we return the receipt, but we never actually add it to the orders. Let's add it to the list of orders and see if that works better. We'll run this test once more. And now it passes. Great stuff. Time for a break.